Welcome to Network Analyst Automating Workflows with Geoprocessing. My name is Patrick Stevens, and this is my coworker, Dilesh Mandloy. We are product engineers on the Network Analyst team. What product engineer means is that we do everything except for the core C++ development that the developers do. Testing, designing, documentation, demo theaters, and tech workshops, those kind of things. I'd like to get a gauge on you guys, though. How many of you currently use Network Analyst? Quite a few. So I'm going to cover the basics of what Network Analyst is, but we're not going to go too in-depth on Network Analyst itself. So if you're new to Network Analyst, there's presentations later today for an introduction to Network Analyst and performing network analysis that'll give you some more of the what Network Analyst is and does. How many of you currently use Geoprocessing? About the same number. That's good. Same idea. I'm going to cover Geoprocessing from a high level. We'll focus on the Network Analyst workflows within Geoprocessing rather than a what is Geoprocessing kind of session. What about Python? How many of you have worked with Python before? A couple of you. Same idea. Briefly on Python, but mostly how to use Network Analyst within Python. And there's plenty of sessions about Python and Geoprocessing that you can go to. So today, as I said, we'll cover the Network Analyst extension and the concepts behind it. Same with Geoprocessing. And then we'll dig into how to use Network Analyst within models, within model tools, in Python, and with Python script tools, and how to automate your Network Analyst workflows using those different tools. Starting with Network Analyst and the Network Analyst extension. So Network Analyst works on transportation networks. There's another kind of network within the geodatabase called utility networks. There's electrical networks or river networks. Network Analyst is for transportation generally. It's used for streets. And it does this through 6 different what we call solvers, which are 6 different analysis types, as well as utilizing traffic. The first analysis type is route. This is the simple, you've seen this in web maps, point-to-point routing or optimizing the places you visit along the way during a route. You can take into account time windows for the stops as well as using a start time if need be. Closest facility, also called find nearest. The idea behind closest facility is finding, say, the nearest 3 police cars from a bank robbery or the nearest ambulance from an incident where somebody's injured. So finding the nearest location from another location when travel along the street network is the type of analysis you're doing. Service area is coverage. So coverage in every direction driving out from a facility. Say 1 hour, 2 hour, 3 hour service areas from my warehouse, or can customers reach my store location within 15 minutes? So full coverage is what service area does. The OD solver, or the origin destination cost matrix solver, sounds intimidating. It's pretty simple. A set of origins and a set of destinations, and every distance between the two along the streets will be found. So basically generate a table of distances for your origins and your destinations. Vehicle routing problem solver, we call it the VRP solver. This does logistics work. So it does routes in the face of sets of orders and fleets of vehicles, and depots and vehicle specialties and vehicle capacities, the cost per mile of the driver or the vehicle, overtime and brakes, and everything that goes into logistical problems is done with the VRP solver. Location allocation will pick site locations for you in the face of demand. Say you want to pre-position fire trucks. You can set up all of the house centroids and decide where's the best place that you'll have the best coverage on your city for your fire trucks, or where to put a warehouse that'll best cover your customers. And all of this can be done with traffic in mind. Historical or typical traffic, live traffic, or predictive traffic. All of that can be built into your network data set so that time of day becomes important in your routing. Routes can vary dramatically depending on what time you leave in the face of traffic. Oops, skipped a slide. Now all of this is done against a street network. And the way street networks are represented in ArcGIS is through the network data set. It can build in streets and sidewalks and bus lines and alleyways and trails, anything where connectivity is important. I can go from this street and make a turn onto this street. I can go from this street and get on a bus stop here and travel along the bus lines. All that's managed in the network data set, and all the analysis Network Analyst does is done against network data sets. And they can be represented in the geodatabase for SDE or file GDB or access. They can also be compressed read-only or done in shape files too. So whatever type of data you work with, Network Analyst provides a network data set for it. So with street data in mind, there's a lot of places that you can get your data. A lot of organizations have data. How many of your organizations already have street data that they own? Quite a few of you. There's a session called Creating Network Data Sets that'll help go into the nitty-gritty of building and maintaining network data sets if you're interested in that. If you don't have data within your organization, there's a few places you can get it. There's OpenStreetMap, which is crowdsourced, Tiger Data, which is government census data, and some free data that comes with ArcGIS. And all of those are free to use. If you're routing within North America, the free data on the data and maps media, I think you can get it through the customer care portal too, is high quality data that's a couple years old, but it's a great place to get started if your organization doesn't have its own data. Or if you want to route on an area outside of the coverage of your data. You can buy data from vendors, Navtech, which is called Here now, so it's Here data, or TomTom, and we have processing tools that'll take their raw data sets and build them into network data sets that can work with Network Analyst. Or you can buy StreetMap Premium data from Esri, and that is Navtech and TomTom data already built into optimized routable data sets. And now you don't really need data if you want to use the online services. You can pay per analysis, and it'll use the data that we have in the cloud, a high-quality premium data set. And so if you use the ArcGIS.com map viewer or any of the ready-to-use services for Network Analyst, you don't need your own data locally for those. Now, as with a lot of mapping, Network Analyst works with layers. Each type of analysis that I showed you in the beginning, all 6 of those types of analysis, has their own specialized layer that will manage your inputs. You see for a route layer, there's stops as an input and barriers if you have a point polygon or polyline barriers along your streets. And it manages your outputs, like routes for stop. And each analysis type has its own set of different sublayers. So that's the high-level view of Network Analyst. Now we'll do a brief high-level view of geoprocessing. Now any work that we do involves computation, involves storage and management of data, and involves visualization of your data. Geoprocessing is the computation part. You can do the analysis itself, and you can also automate the analysis. And today we're going to focus on that automation. For Network Analyst, we provide a full suite of geoprocessing tools you can find in the Arc Toolbox that cover pretty much everything you can do within ArcMap for Network Analyst. So all the functionality is available as GP tools. So whatever your repeatable workflow is, you can do it with the geoprocessing tools. This includes making those layers we talked about and adding your inputs to it and solving the analysis. It includes a little bit of the work you can do with network data sets, building your network and what we call dissolving, which is taking a network data set and optimizing the size of the streets and how many different edges you have where possible. Publishing services and working with services can be done as well. And there are turns within a network data set. These are constraints on travel along your network. For example, a right turn being restricted. There can be a turn digitized into your network, or an intersection that has a high delay that you added a cost delay to. All that can be managed through the turn geoprocessing tools. And now at 10.2, there's also the ready-to-use services that I mentioned before. And with this, you don't need your own local data, as I said, and there's a set of geoprocessing services that can be put into models and can be used in scripts. And right now we offer closest facility, service area, and VRP as ready-to-use services. Now if you want to use these geoprocessing tools, you can just click one within the toolbox, and it'll open up the geoprocessing tool dialog, and you fill in your settings and run it that way. Or you can chain the tools together to do a workflow. And you can do this through the Python window within ArcMap. You can build a model and do it that way. Or you can write a Python script and run it that way. And we'll talk about each of these ways of working with Network Analyst. So anywhere in the ArcGIS suite of products, be it mobile devices on the web or on the desktop, through all of the SDKs offered through Esri, Network Analyst is available. And it's available via those tools that you saw before. And you can also build model tools, script tools, and use those built-in tools. And we'll go through each of those different types of workflows as we go on. Starting with models. Now, this 4-step workflow, I'm going to repeat throughout this session. It's generally your workflow for network analyst. And whether you're working in models or scripts, it's going to be the same type of workflow. Starting with creating that analysis layer that I talked about at the beginning, specific to your type of analysis. Adding your locations. This is the way Network Analyst works is you create your analysis layer, you import your stops into the analysis layer, for example, and then solve your analysis. So you created your layer, you added your locations, you solve your analysis, and you work with the results. And working with the results varies depending on whether you're working in models or scripts, and we'll cover the techniques for working with Network Analyst results in each of these workflows. I'll switch over to Dilesh, and he'll get us started with geoprocessing models.
Okay. Thanks, Patrick. So in this case, we'll look at a scenario where you want to find a route. You work from your home office, which is in the center of the map here. You want to visit these 5 locations because you want to verify their insurance claims. Then you want to return back to your home. So in this case, you're trying to find a route that will optimize the sequence in which you visit these 5 intermediate stops and then return back to home. We'll first see how we do this workflow using the user interface in ArcMap, and then we'll build a geoprocessing model to automate that same exact steps. So before we start, let me add the Network Analyst toolbar and dock it here. So I have now, for the claim locations, here I have certain service times. So this is the expected time I would spend verifying the claims on each of the addresses, and these are the time windows during which I want to visit them. So when I'm building my route, I want to incorporate all of these rules. So in Network Analyst, as Patrick mentioned, we have the 4-step workflow. First step is to create the layer. I want to find a route, so I'm creating a new route layer. I have my route. Now the data that I'm using here is the streets data that Patrick talked about, comes free with ArcGIS for whole of North America. So this is the data and maps DVD that comes with the street network dataset that I'm using here. I've added it to my map document, and now I can run all of my analysis against it. So I've created my route layer. The next step is I want to set some analysis settings. So in this case, I want to minimize my time. I want to use time windows because I have to visit stops during certain times. I want to reorder my stops because I am finding the best sequence in which I want to visit them. All other analysis settings are fine. I go to the network location tab. I say I don't want to locate on restricted portions of the network when I load my locations. So my settings look good. Now I'll start loading my stops. So I'll click my stops, say load locations. So now I want to first start from my home location. I'm mapping the name. So I have my home first location loaded. Then I want to load my claim locations. Now here I'm mapping the name, the time window fields that I had. So the time window start is mapped to the from time window field. Time window end is the to time window, and the ATTR_time is the service time. So that way when I'm building my route, it will incorporate that service time into my route. So I load that. Now I have that. I want to return back to my home. So I'll load that as my final location. So now I have got all my 7 stops. The next step is to solve it. So now I got my route in which I want to visit. So I start from here, visit this way, and then come back here. So this is my route. As you saw, I did a lot of steps. I created the layer, I set the analysis settings, I loaded 3 times my start location, my intermediate locations, my end location, solved it. Now let's see how we can automate this so that you can do this with one click, and we will use geoprocessing models for it. To make your own models, you need to do them in your own toolbox. Network Analyst comes with its own set of tools. So within the Network Analyst tools in our toolbox, we have all the tools that Patrick talked about. We'll focus on the analysis tools and how we can automate this workflow using the tools that are in this analysis tool sets. So to create our own model, we need to first make our own toolbox. So I am in this project folder. I'm going to create my own toolbox, call it my tools. Now I'm going to create a new model here. So let's give this model a name. Let's call it best model. Give it the same label. Make sure I use relative paths. Save it. Now I'm going to build this model. To build this model, I need to add tools to it. So I'm going to drag and drop. So first thing that I did was, again, this is the 4-step workflow, is to create the layer. So I'm going to create my route layer. Now in this case, this tool right now is white in the model builder canvas. That's because I haven't specified any parameters. So I open the tool dialog. I specify my network dataset. I specify a name. I specify the same settings that I did in the user interface. Reorder stops, preserve both, use time windows. For all other options, we're fine. So say OK. And now you see the tool has changed color, which means it's ready to be run inside the model builder. So let's save our model and continue building our model. The next step I did was I added my home location. So let's connect this and open the properties or the tool dialog and specify I want to load it into stops of my route layer. I want to load my home location. So I'm going to specify that. I'm doing the name, and then I am going to specify the exclude restricted portions. So that's this setting here. So that way I don't locate in there. So now I have my second tool ready. Let's readjust the canvas, save this model. Now I'll add the third one. And it always happens during the demo time. It's actually crashing at this point. That's why I was insisting on saving it. This has been a bug for a few years now. It only happens in user conference when I'm doing the demo. So. Yes. That's why it's always a good practice to keep on saving your works so that you can get back. So I'm back here. Let's try it a different way. You can drag tools from the toolbox. Most of the time it works, unless you are on this chair and doing the demo. Or you can also add it from here. Let's go ahead, and in this case, we are going to add our claim locations. We are doing the field mappings. We are making sure we exclude. And the other important setting here is I'm saying append. So I loaded my first location. I'm saying append to those existing locations. That's because I'm loading into the same sublayer. I'm loading into the stop sublayer. So I don't want to override my first point that I've already loaded, but I just want to append to it. So I'm using that append setting. Make sure I save. So if I want to start again, I can come back. Let's see if we get lucky now. I don't want to. I'll still do it the way it works. So now I'll add my home location again. So because I'm returning from home, I have that. The last step we do add is we add the solve tool. Let's get back here, add our solve. So now we have our model that we have done. Let's add this to the display and run. So now it's doing all those steps, but doing this with one click from the run button. And now we have that same route. The same route that we created from the user interface, we did it from the model builder. So that's cool. Your colleague saw this, and he also does the same kind of routing, so he wants you to share this thing with him. So he said, okay, fine. You know that you were using your home location and your claim locations. You want him to use his claim locations and home locations. So you made those two things as model parameters so that he can specify the values. You saved it, and let's say you shared this model. Now your colleague comes back. Let's get rid of this layer. He gets the model from you. He opens it. He sees it as a tool. He is not familiar with model builder or anything. All he specifies is, he specifies his home location, his claim location. For the sake, we are using the same values here, but he runs it, runs the model, everything succeeded, no red lines here, but something is missing. The output is not being added to the table of content. He calls you and says, okay, the model ran fine, but I'm not getting the output. You're a bit surprised on, you were getting it when you ran it from within the model builder, you ran it, you got the outputs, but when your colleague is running it as a model tool, he's not getting the output. Now the reason for that is, and this is something that most users, when they get started with Network Analyst and Model Builder, find difficult, is your model has the two model parameters that act as inputs, but your model does not have any outputs. When you say add to display, it's only applicable when you run it from within your model builder canvas. It does not, this setting is not honored when you run it as a model tool outside of model builder. To do that, you need to make your outputs as a model parameter. So I did was, I took my final output and said this is a model parameter. Let's save this out. Let's open the model tool again. Again, this is an output that will be created by your model. So it will not show up here because the end user have no control on where that output is being created. Specify my inputs, run it again, and surely now I have my outputs automatically added. So when you run your model as a tool, make sure you have something that is output from your model. So in this demos, we saw that we can easily share models as tools. We built a model and then we shared it with our colleagues. We saw that if you run models as tools, you need to make sure you have some outputs from it. If your output is a network analysis layer, you make it as a model parameter and then it gets added to the table of contents. Network analysis layer is derived output, meaning the output is created for you. You don't specify a location where you are creating the output. It's created inside the memory of the process that is running ArcMap. Back to you, Patrick.
Thank you, Dilesh. So you saw Dilesh working with models. And the reason you would use a model instead of just tools is that you can link them together and do the whole workflow, that all four of those steps, creating your layers, adding your locations, solving, and working with the displays. All the other model builder techniques that you might learn in other parts of ArcGIS are applicable to network analysis as well. So you saw Dilesh's model that he did and those 4 steps. So I'll repeat them because they're important. It's creating your layer, adding your locations, solving, and then working with the results. And the big trick Dilesh showed you is the model parameter on the output. And that way, when you share your model, it will appear in the table of contents and can be worked with that way. There's another tip for network analyst, and that is select data. You saw Dilesh made the output network analysis layer a model parameter, so the whole route layer appeared in the table of contents. If you just want to work with one of the sublayers, for example, the polygons of a service area, or only the route shape for the routes, then you use select data to select that specific sublayer out of your network analysis layer. Most other tools take layers as inputs, don't take network analysis layers as inputs. So if you're feeding your analysis outputs into another tool to do other work, quite often you'll do it using a sublayer, and you use the select data tool to do that. And Dilesh will show you just exactly how that works.
Yeah, thanks, Patrick. So we'll have a different scenario for this second demonstration. In this case, you work as a GIS analyst for a taxi company, and every day you receive a CSV file which looks something like this. So what this CSV file has, it has an ID for each row. It has a starting address broken out into 4 components. It has an ending address broken out into 4 components. So in this case, I have about 30 such start and end pairs. Now your job as an analyst is to find a route between each of these start and geocode them, find a route between each of these start and end pairs, and then store all of those routes into a geodatabase feature class named with the date on which that CSV was created. So you need to do this every single day. At the end of the day, you will get a CSV. You need to convert that into routes and store that routes feature class into a file geodatabase. Now, yes, this will require automation. So your manager also had this idea that this should be a button on the ArcMap interface where you click the button, it opens a form where you specify the CSV. It has another location where you specify a file geodatabase where the outputs are written, and then all the analysis should be done behind the scenes. So this is the task given to you. Now, we have seen buttons on the interface. well, geoprocessing, I don't know if I can do that. Maybe I need to do VBA, but I don't have time to learn VBA. I need to do this in a few hours. That's normally how we get tasks, right? It needs to be done immediately. So let's see how we can do this using geoprocessing without writing any ArcObjects code. We'll get a button that will do this analysis for it. So I used the same steps that I showed you before to build a model tool which did this analysis. So that model tool is sitting here within the routing tools. I created find daily routes. This was the one that I created in the previous step from scratch. Here I'm not going to repeat all those things. Instead, we are going to see first how we can add this model tool to a button on the toolbar. For that, I'll go to the customize menu, customize mode. I've already added a new toolbar called My Useful Tools. I'll open that toolbar, go to the commands mode. You can add any geoprocessing tool as a button on the toolbar, whether it's your tool or tool that comes with ArcGIS. So I select this special category called geoprocessing tools. Then I click add tools. I browse to the folder where I have my toolbox, in this case find daily routes. So I see that as a button. Now I can go back to my tool, drag it, make sure I show the image and text. So now I have a button that I can click, which will open this tool dialog. So I'm launching a geoprocessing tool as a button on the toolbar. So that way, if someone is not familiar with geoprocessing and all they are used to is buttons on the ArcMap user interface, you can do that. Let's give it a few more seconds. Hopefully it's not crashing on me again. Okay, so there the form comes up. Now I made my two parameters in the model. The first one was the CSV file. The second is the geodatabase in which I want to write the outputs. So let's run this. So now what this model tool is doing is it's taking the CSV file, taking all the starting addresses, geocoding them, taking all the ending addresses, geocoding them, then creating routes. Now as you see, we are doing 30 routes here. So it's not doing 30 different network analysis layers and then doing 30 routes and then exporting the routes. Instead, it's doing all those. Okay, finally it's on its way. Okay, let it run and I can continue with my explanation. So it's doing those 30 routes in a single route solve. Once it's done with those 30 routes, it's exporting those routes into the geodatabase feature class. Hopefully. Where is our tool dialog? Oops. Okay, it's still running. Okay, so the tool completed finally. And we have our routes here, but at least it did everything in one single step. I don't have to run multiple steps. So let's look at one of the route here. And as you see in the outputs, we have the start address, the end address, the total time, and the total length. So this was the output that we wanted to achieve. Now let's look in the model and see how we did that. Make sure I have the full screen here. So on the top here, I have those same 4-step workflow that Patrick was talking about. So the first step that I'm doing here, let's zoom in. So first I'm doing the make route layer to create my route layer using the streets network data set. Then I'm using an address locator again that comes with the data and maps. I use the geocode address tool. This is my CSV file that I showed you, and I create my start addresses using the geocode address tool. Here the tool is not really called geocode start addresses, but just to make my model more descriptive, I've just renamed that element to be geocode start addresses. So in this case, I'm taking my CSV file. These are the fields from the CSV file, and I'm storing the outputs into a temporary in-memory feature class. Same thing for geocoding the end addresses. Once I have my start address, I use the add locations to load these into my stops layer. So now, as I told you, we want to do 30 routes in one single solve, and this is the most important trick in this demonstration is I'm using the ID field, the ID that I had on my CSV as the route name field. What this does is it will do all the 30 routes in one single solve. So it will say all stops that have the same ID belong to one route. So in this case, I have 30 stop pairs. So I have 30 starting locations, 30 ending locations. Each of them have a unique ID, and so generate me a route for each of the unique ID pairs. This is very useful trick that many people seem to miss, and they might do this as 30 different solves and then combine the results. Actually, that's not required. With route name, you can just map any ID field, and that way you can do multiple solves together. Rest all things are the same that we saw before. We added our start locations and end locations the same way. If we see, we do the same thing with ID even in this one. So we map the route name field to the ID field. We have done the exact same thing here too. So once we have this, we do the solve. And now we are interested only in the routes from within the entire route layer. So as Patrick was mentioning, we use the select data tool. In this case, we use the network analyst layer and only selected the stops. And here we are only selecting the routes. We are not selecting all the other sublayers that you may get. Now, why we are doing this? Because we want to extract the addresses, the start address and the end address, and append those to the final routes that we got. To do that, we are using this join field tool. Now, the output routes from the network analyst route layer has a field called object ID. The routes have a field called first stop ID, and the stops have object ID. So those two are common identifier fields. So I'm using them to join the name field from my stops to my routes. The same thing I'm doing to get the ending address. I'm joining based on the last stop ID. I'm joining the object ID from the stops to the last stop ID on the routes and transferring the name field. So I have the start and the end. I'm parsing the path so that I can get the name of the CSV file here, and I'll use that name to create my feature class using feature class to feature class tool. If I open this, I'm doing some, the name is coming from here, and here I'm renaming my field. So on the routes, I'll get a name underscore one field after the join. I'll get a name underscore 12 field after the join, and I'm renaming it to start address and end address. And the other fields I'm not renaming them, so I'm leaving them as is. So then this will result in the final feature class, and I'm doing a delete of, let me zoom out. So once I'm done with my output routes, I'm explicitly deleting this network analyst layer. I'm deleting this network analyst layer as the last step. Why am I doing this? Because this is an intermediate output and I don't really need to use it. So I'm explicitly deleting it so that it will free up memory on my disk, in my system, sorry. So that was so what we saw in this demo was so we use the select data tool to access the sublayers from the analysis layer. We can incorporate external data, like we saw how we can use CSV files in this example. We automated a complex workflow without writing any code. We made sure our model was added as a button to the toolbar also. And we saw if your network analysis layer is an intermediate data, then we explicitly delete it so that we can save up some system resources. Back to you, Patrick.
Thank you. All of these models are available if you want to use them. We can provide them to you. Very helpful. So you've seen models and model tools, and now we'll start talking about doing this same kind of automation through Python. And the reason you would use Python instead of Model Builder is that you get all the power of the Python language, all of the looping logic and conditions you can set and cursors to work with, and you also get the ArcPy site package. So it's some additional helpful functionality that's easy to use and available to you. And there's a few network analyst functions within it in the network analyst module of the ArcPy site package. You see here on the left all of the geoprocessing tools we talked about before from the toolbox. Those are all available in Python through the ArcPy site package network analyst module. And there's also some helpful functions on the right. For example, working with your layer properties. It used to be that you had to recreate a new layer anytime you wanted to adjust properties, but using the network analyst module, you can update the properties manually, along with some other helpful functions. It also can speed up the execution of the scripts, make the scripts a little simpler, and I'll show you how that works, especially with field mapping as we go on. And this, you can use all this through the Python window, not just through external scripts, but through the Python window as well. So the basics of a Python script, you'll see that same four-step workflow that we talked about earlier with models and model tools. But first, with Python, you want to import ArcPy and make sure to import any other modules you might be using, third-party modules or Esri modules. For network analysts, you need an extension license. When Dilesh was showing you ArcMap, he had the extension, network analyst extension turned on. Through a Python script, you'll have to check out the extension license within your script. The way geoprocessing works in Python is with string names. So a good idea is to set up all of your inputs and outputs as strings. In this example, we're working with, it looks like a closest facility layer. So setting up the input facilities and the input incidents, what your impedance is, all the settings you saw on the geoprocessing tools, you can set up as strings. And the first thing you do is step one of that workflow that we saw earlier. You're going to make your layer. In this case, it's a closest facility layer, and you see all those inputs and outputs are used in the creation of the closest facility layer. To get the output layer from the result object, you do it with the line below, and I'll talk about this a little more, using get output from the result object to get your analysis layer. I'll cover that in a couple of slides. The second step of that four-step workflow is adding locations. So you do importing the same way. In this case, we work with some field mappings. Say, for example, the locations you're loading in as facilities have a name field called NOM, and you want the data from this to be copied over to the name field for facilities. You set up a field mapping from the NOM field to name, and that'll pull that data in along with the locations. Step 3 is solve, and step 4 is working with the results. You saw with in Model Builder, you use add to display. As a model tool, you used a model parameter. With a Python script, if you're running the script externally, you want to save your analysis layer out. You can save it as a layer file. And this is a layer file on disk that will have all of your data in it. So it doesn't need to be in a geodatabase. All your inputs and outputs are stored within this layer file. And you can work with them that way, drag them into ArcMap or work with them in other scripts. So I mentioned earlier the result object. And when you make a closest facility layer, you get back a result object. You would think that's your analysis layer. It's not. It's an analysis layer along with some stateful information. So did the geoprocessing tool succeed, for example? So in order to get the analysis layer out, you get that first item out of the result object. And that's why you see get output 0. The first item in the result object is your network analysis layer that you can work with. So I mentioned earlier the get solver properties function available in the network analyst module. Now you do this to get these the analysis settings for your particular type of analysis. In this case, it's a service area. So perhaps we want to change the breaks and resolve the service area, or turn hierarchy on or off. And you can do that with get solver properties, where previously you had to recreate a new layer and set the properties there. So we saw select data used within the model tools to get to sublayers. Within a Python script, you're not going to use the select data tool. You can get the sublayer out by name. And Dilesh will show you that when he demos Python scripts. So I mentioned field mapping. At 10.0, you had to know the the syntax of this big long field mapping string. You see here mapping precipitation barriers and ATTR underscore fields, all of this internal to Network Analyst fields if you want to do mapping over to it. Now with the Network Analyst module in the ArcBySite package, you can do field mapping in a much more descriptive, easy to understand way. And saving to layer file, I mentioned before. This way you can have a layer file on disk and use it within other tools or drag it within ArcMap. I'll pass it to Dilesh and he'll show you everything in action.
Yeah. Thanks, Patrick. So in this, we'll go back to our first scenario where we were having the claim locations and how we built a model to automate this route. Now we'll see how we can make a Python script to do this exact same thing. Now, there are multiple ways to write Python script. If you are comfortable with Python, you can just probably open a tool. In this case, I'll go to the Network Analyst toolbox, the solve tool. You can open the help for the tool, and each of the geoprocessing tools help comes up with a detailed Python example. So this is how you will run it from, oops. So this is how you will run it from the Python window, and this is the whole complete standalone script example. So this shows the same steps that Patrick was talking about. You import, you set the outputs, you set the layers. So if you are proficient with Python, you can just look at the code sample and then build your own code. Other ways to use the geoprocessing tool is you can open the Python window. Let me get my execution area, and you can start typing in source code, and the IntelliSense will help you. So in this case, I am trying to run the solve tool. I am trying to solve the same layer that I had before, route 2, and I'm going to solve it. Now, this is working Python code. You can take this, copy paste in your script. So this is another way to do it. One other way is, which is what I find most easy for everyone, is you can make models because it's a visual tool, and then you can export your model. You have export to a Python script. So that way, whatever is in your model will be converted as a Python script. Now, before we do that, in this case, we were making a model that we were running from within ArcMap. When we are writing a script in this case, we want to run it outside of ArcMap. Say, we want to run it at a command prompt and run it during lunchtime because your script may take more time to run. We don't want to run it from within ArcMap. ArcMap won't be running. But if you saw the inputs for this model, we were using a layer that was in the table of contents. So if we export this model as is, you will just have the reference to that layer, and then when you run the script outside of ArcMap, your script won't be able to find that layer. So what we are going to do is, instead of pointing this home locations and claim locations from layers, we are going to use the actual catalog paths. So once we have the catalog paths in our model, and then we export our model as a script, it will take these catalog paths and put these catalog paths into the script. So we have that for the home and the claim locations. Let's make sure we have that for the streets too, because this is also a layer. This is in this location. So this was my streets. So I put in the full catalog path for it. Let me save my model. Oh, I didn't. Thanks. Thanks, Patrick. So let me get back my claim locations. So I have the catalog path for my claim locations too. Let me save this and now export this to a Python script. Let's call it best route script. Save this out, go to this location, and there we got our Python file. Let's open this in idle. So this is the script that was created from Model Builder, and it does a lot of steps for us. So if you are new to Python, this might be a useful way. You can get most of your source code written, and then you can make some changes. And if you see, this is what I was using the catalog paths for. So I don't have to specify my script would work as a standalone script. So my home locations, my claim, my streets network dataset. This export to script isn't doing the proper job. Sometimes it will create this cyclic code references. So it's using, it's creating a variable called route2_2, which is route2, which is, that's okay. But then it's using that same thing and recreating it again and again. So what we are going to do is getting rid of all these things. Get rid of it. We have a variable here called route_2, which is the name of our route layer. We will take this variable, and wherever we are using that route layer, we will reference it with that variable. So this is just to say that we are doing the analysis on that same layer. So we are running the make route layer tool and creating a layer called route2, which is being referenced by this variable. Take that same variable being used here in add locations. Then the same variable is used here, this step 2, and finally in the solve step 2. So this will solve. Let's save this. Now in this case we have solved, the layer is in memory. Now we want to save that as a layer file. So Patrick showed us, let's add some lines here, how we can use the save to layer file tool. Now if you don't know how to add the save to layer file tool, you can run it from here. ArcPy. So you have the save to layer file tool. You can use the route2, give it a location. In this case, we want to save it in this folder with the name here called best route. Close this out, run this. So now this ran and it saved the layer. It also added an entry into the results view. Once you have that entry, you can right click that, say copy as Python snippet, and then that snippet is something that you can paste in your script. So I'm back in my script, I can paste here, go back home. So it's just saying do some replacing. So we are not calling this route2, but we were referencing that layer by the variable name. Let's put this here, and we want to save in this location. So that's fine. So let's save this. So now we have our script ready. Now we can run this script by saying run module and it will run here, or you can run it from a command prompt. So in this case I am in that same folder and I can go there and run my best route script. So in this case it's doing all those workflows. Now why am I showing you this way? Because you don't have to really run stuff from within ArcMap. That's one advantage with Python, is you can run them as external scripts, so that if you have some long running process, something failed. So it says best route already exists. Let me really delete this that I created in the previous step. Rerun this again. So it's useful to run scripts standalone, because that way you can run them at certain specific times of the day or in the evening when you are done. So now it ran fine. Let's get back. Yes, it has added the layer. You can drag that layer back, and you have that layer within the user interface. So from this demos, we saw that the network analysis layer can be referenced in the scripts using their name. We were creating a name of a layer called route2, and then we saved that name in a variable and then use that variable with all tools that would take the network analysis layer as input. We use the save to layer file to save the layer file, and we also saw how we ran the Python script at the command prompt.
Thank you, Dilesh. So you've seen models, model tools, and Python scripts, and the final part is Python script tools. So with the script tool, you could see, for example, the script that Dilesh made as a user interface within ArcMap. So you can double-click the script that you wrote, and your inputs and outputs will show up in the user interface. So you'll get a nice, convenient UI in case you're sharing with a coworker that's uncomfortable with working on a command prompt, for example. So once again, you have to work differently with your output data. We saw with a add to display in Model Builder, model parameter for model tools, save as layer file for your external Python script. And you can also, with the Python script tool, you need to use set parameter as text. And this way, the tool will know what your inputs and outputs are so that they can appear in the UI for your tool. And Dilesh will show you that right now.
Thanks, Patrick. So last step, we saw how we built a standalone script that is residing here, best route script that we ran from the command prompt. Now we'll see how we can add this script as a script tool. The whole purpose of doing a script tool is to provide a user interface and to make your script into a tool that you can then use anywhere. So in the very first demo, we created a model. In that same toolbox, I'm going to add a script tool. To add a script tool, you right-click your toolbox, say add a script, give it a name. We'll call it best route script tool. Copy this, save. You have to give the path to the Python file which we had created in the previous step. Next. Now we want some parameters on our script. So in this case, we want the home locations. So this is of type feature layer. Then we want the claim locations. Press some other key. So we'll get the feature layer from here. We have our home and our claim locations. Let's finish this. So now we can specify our home location, claim locations, and run our script. So now you saw how we getting some errors. Let's look at our script, fix the errors. This is part and parcel of writing code. You get bugs, you fix the bugs, and then you work with the stuff again. So it's complaining here because we don't have a parameter set. So let's comment this line out. Saved it. Let's try running it again. Okay, so it completed, but as you saw, we're not getting any outputs added back. The same thing we saw with the model. Once you make your tools, you need to make sure it needs to have some outputs. So here we have the inputs, but no outputs. So we will create an output layer. This is our network analysis layer. So we'll say network analysis layer. In this case, this is not an output that someone specifies, but it's a derived output. So we'll keep a type derived output. Get back to our script. And then we need to use the set parameter. So let the script know that this is the output, but we don't want to save it as layer file anymore. So let's comment that thing out. Say arcpy.set. Now this was the third parameter that we added, and the parameter that we want to add is our route layer. So I do that change, save this. And now let's rerun our script tool. As you saw, we added a derived output, so derived outputs don't show up as tool parameters. So we again say specify the home and the claim locations. And now you saw the output layer is getting added. So again, you need to have a parameter of type output on your tool so that it can add the outputs. Now, this is a simple script tool that I showed. Now you can build script tools and it can take all the advantage of Python. So this is one example script tool that I wrote. It's available on arcgis.com. You can search for allocation tools for ArcGIS. Now what this tool is doing, let me start up a map document so I can show this. What this tool is doing is It's actually doing some allocation with capacity into consideration. Now we have the closest facility solver in ArcMap which can find the closest facility. So in this case, say you want to find the closest school to each of the student locations, but schools have a capacity. So you don't want to allocate more than the capacity of the school. You want to consider that capacity into account. This capacity is not available with Network Analyst. So what I did was I wrote a script tool which uses a linear programming package, and it will do this optimization inside the linear programming package and then would give you the results back in ArcMap. And so for an end user, it appears that the script tool is doing everything, whereas it's calling two different components. So you can get quite advanced with the script tools. So this is, for example, we'll see how we run this thing. So these are all my student locations. Let me open the attribute table. At every location, I have only one student. These are all my schools. The schools have certain capacity, so you don't want to allocate more than this capacity. And this is the script tool that I downloaded. I constructed this using the same principles that we have been seeing here. So this is my script tool. It has all these different parameters. I am specifying my origins and all. So let me run this thing. So again, I've provided the documentation also, which you can do for your own script tools. So I'm providing students, and they have a number of students at each location. The schools, this is the capacity. I'm specifying my network data set. Now, as I specified my network data set, everything else that depends on the network data set got populated. Let me specify a wrong value. And you'll see there's some validation. It's saying this does not exist. And all the fields that were dependent on the network data set are all cleared out. So you can, the idea of showing this is you can, oops, I hit enter. So it's running it. The idea of showing this was you can do validation as part of your script tools. So right now it's doing all this analysis. It's first creating an OD cost matrix, then calling the linear programming solver, and it's doing the allocation. So if we see, once this school got filled up, it started assigning some of the students to other schools. So probably this one is closer to this one, but because this is already full, the school, it's going to the other school. And also you saw the outputs has some predefined symbology. So it's showing the ones in the green, and if I had something that was not allocated, it will show in the red. Now, where is all this coming from is when you define the script tool, along with the input parameters that you're defining on the outputs, you can define the symbology. So I'm saying when I draw the outputs, the symbology for that outputs should be determined from this layer. So that's why when the outputs are created, they are symbolized from this layer file. And all that validation logic that I was showing when I selected a network data set, it would fill in all the properties. That can be programmed by, again, writing some Python code within this tool validation, which is a separate Python class, Python code, where you write all this validation logic. This is where I was doing all that logic on when I select a network data set, everything else get populated. Not going to show the source code. It's quite an advanced piece of code. So this tool is available on arcjs.com. You can go ahead and download it and look at it, or just use it as a tool. So as part of, switch. So we saw as part of this demonstration, you can write script tools. Let me get back to the. So you can use the set parameter as text, and you can provide custom validation logic like I was doing in the allocation tool. You can also predefine symbology for your output, so that way when your outputs are added, they have a nice looking feel. Back to you, Patrick.
Thank you, Dilesh. So that's it for talking about geoprocessing. I'll do a couple summary slides. New intent 2 for geoprocessing is the global ready-to-use services. You see them here on the right, especially. There's geocoding and there's traffic, but the GP tools are closest facility service area and 2 different VRP tools. One for synchronous and one asynchronous. The synchronous used for solves that take less than a minute, asynchronous for bigger jobs that could take a little longer. And these global ready-to-use tools can be dropped into models or used in scripts. And they use a premium network data set that's stored in the cloud, so you don't need your own local data. So summarize. Now, the network analyst tools are just like all the other system tools in ArcGIS. You can use them in exactly the same way, along with the tips that we showed you specific to network analysts. And it usually involves working with the output and different ways to work with the output. We went through models and model tools. You saw the add to display and model parameters, scripts and script tools. You saw save as a layer file and set parameter as text, all very important things. And the reason why you would do this is to take your network analyst workflow and be able to run it repeatedly, as you showed. And although I love writing ArcObjects code, it's a little bit easier to do. Python scripts, these modules are set up to have a big analysis type, so you aren't working directly with all the fine-grained details that ArcObjects provides. So there's a lot of support and help for you in working through these processes. There's tutorials. If you're just getting started with Network Analyst, I highly, highly recommend that you go through the Network Analyst tutorial. You can find it by searching Google. It's on the Resource Center in the online documentation. That way you can step through each of the different types of analysis for Network Analysts and working with network data sets, and it'll give you a good grounded understanding of the whole process. You saw Dilesh show the help for geoprocessing in Network Analyst. There's a lot of sample code in there and sample tools, so you can use that and it gives you a good place to get started. There's support for Python and for geoprocessing. The Network Analyst discussion forum online, it's the user forums, but our team monitors that and answers questions. So if you don't mind, with tech support, you'll get an answer right away. If you don't mind waiting a little bit for us to be able to get to it, usually less than a day, you'll get a good answer specifically from the Network Analyst team about Network Analysts on the Network Analyst forums. You can find that searching on the internet as well. Here at the Users Conference, we have quite a few sessions for Network Analysts. There's Introduction if you're just getting started. There's Performing Network Analysis, which is being presented one more time tomorrow, and that's where they'll get into all the different functionality available with the different types of analysis. There's Creating Network Data Sets. If you're working with your own data, I recommend that. Alan takes the government census data, Tiger, and builds a network data set out of it there. And there's also Working with Online Services, which I believe is presented one more time. Might not be. All the ones in purple are demo theaters. There's demo theaters specific to each of the types of solvers for VRP and location allocation. You missed the 3D one already. If you're interested in 3D, you can come talk to us on the Network Analyst Island and we can work with you on that. And I have this as a printout. It's not here, but our team is manning the Network Analyst Island in the Analysis and Geoprocessing section of the showcase below. You see a big Analysis and Geoprocessing sign on one of those columns, and we have our own table there with 4 computers. If you have further questions after this presentation, there's developers there and more product engineers from the team, and we're happy to answer your questions or work through any problems you're having currently. Oh, and we support transit schedules now through a custom evaluator. So if you're interested in using GTFS data, the Google Transit specification, to get bus schedules, for example, that can be built into a network data set as well. There's also user and other team presentations that involve network analysts as part of a greater workflow, be it with StreetMap Premium, with transit, with property management, and so there's some sessions available there as well. Please fill out a session evaluation for us. We read those and we use all of your criticism, and I'll love all of your praise if you do that. And we'll change the presentations based on the feedback we get from you. So if there's something you think we missed or we need to focus more on or a workflow that you want to hear about next year, then let us know and we'll include those in presentations. And this is the offering ID is the first one. So 1364 for this offering ID. Thank you very much. And right now I'll open up the floor if you have any questions. Any questions? Yes.
Which one? The one about the errors of okay, the allocation tool or the okay, so the question is all the demos and the scripts that we showed, they will be on the conference site. So when you go to esri.com, there's a proceedings page. That's where you can get the presentation, as well as there will be a zip file with everything that we showed. And we'll also put this on arcgis.com. There is an ArcGIS for Transportation Analytics group. So we'll also put the zip file there so you can download all this and use it.
And if you have any troubles using it, you can contact us directly or post on the forums, and we'll help you out then. Yes, sir.
Give a word or two about historical time, historical data and real time. Sort of a session afternoon. I don't know how.
Using historical traffic data. So some network data sets have historical traffic data. The question was, can I give you some more information about using historical traffic in network data sets? So what's that?
Outside of the USA.
Outside of the USA. So those global ready-to-use services do incorporate traffic. So you can visualize traffic just about anywhere in the world. And you can also include it in your analysis if you use a start time in your analysis. It'll take into consideration historical and live traffic.
Yeah, so I can just switch to, okay. So the question is what historical traffic data that we have available. So if you go to arcgis.com, search for network dataset coverage. So this will give you ArcGIS online network dataset coverage. So this is currently the web map of all the areas that we support with ArcGIS Online. So any particular place you're looking for? No. This was not. Let me search it again. Okay, so in this case, you can identify this map, and it says we support historical averages, no traffic incident, and we support logistic attributes. So if you were to sign in and then do routing here, it will use the historical traffic data. So it's available as part of ArcGIS Online. The services that we have will have support for historical traffic in the countries that we support. Yes, so the question is, can we drag that service into the model? And the answer is yes. So in this case, if I sign into ArcGIS Online, let me sign in from ArcMap. So once I sign in, I get this ready to use services. Within this, I have the, collapse this. So then all these are the services that are available. They are just GP tools. So just like we saw the tools within the network analyst toolbox, these are the additional tools. You can open them like any other GP tools and then execute them. And this will use the global data set that we have.
Any further questions? If that's it, if you have anything you want to talk to, you can come up and talk to us now. And we're also available the rest of today and tomorrow through 1 o'clock, I think, on the Network Analyst Island. Thank you very much.